Dmytro Karamshuk from King's College London's talk on CD gain.
Hello everyone, I'm really glad to be here today, and I want to talk about this project which we have been doing with, in collaboration with Research and Development Unit in BBC, which is called CD gain, measuring traffic gains from peer-assisted content delivery of long-duration video-on-demand content. So, a bit about the context. So, BBC had this iPlayer, which is on-demand service, where you can watch all, not all, but almost all programs from BBC after they were officially broadcast. And so far it has been the second source after YouTube of video on demand in the UK. And it accounts for as much as 10% or even more than 10% of UK's net traffic, at least as of 2012, this stats. And yeah, it's the leading internet TV in the UK, and well, accounts for around 40. So the audience accounts for around 40% of UK's population. So we have this immense traffic happening here, and in this work we were looking for a solution to offload this traffic, and we tried to play with the peer-assisted content delivery, where basically the idea is to offload the traffic by exploring assistance of peers. Which is somehow not super new, because the BitTorrent was there for quite a while, but in the peer-to-peer literature, they were mostly concentrating on availability and minimizing the waiting time of users. While here, what we are interested to look at is how much traffic we can actually offload. So, obstacles. Obviously, there are a number of obstacles which can happen in realistic deployment of this concept, and one is coming from the fact that basically ISPs don't like the peer-to-peer traffic in between. So we want to try to avoid inter-ISP traffic and localize peer-to-peer communications inside ISPs. Then different users may want or may require different quality formats, and so that we want to provide users with the bitrate that they want, that they require. And we also have to account for partial participation, and so that we need some maybe incentives for people to participate in this deployment, and many of them may opt out. And there are many other problems, such as asymmetry of upload and download bandwidths. And so we try to face in this project this problem, firstly, by developing a simple analytical model, where basically what we're trying to measure is I'm coming from academic, so you will see a bit of formulas here, but I will try to make it simple. So basically, what we're trying to measure is the amount of all traffic that we basically can save in this deployment, and for a given content, we introduced a measure which we called swarms capacity, which basically is a product of arrival rate of users for a specific content, or in other words, it's popularity of a content multiplied by the duration of a content. And basically, our analytical model, if we play a bit with mass of infinite queues, infinite service queues, we can basically derive a formula which expresses the gain that we can achieve in this deployment. And as you can see, this gain function, gain can be expressed as a function of a swarm capacity. And then we obviously can have multiple swarms, so we can have a swarm for bad education series or for EastEnders and another swarm for another content. So basically we can also express using this mathematical toolkit, we can also express the gain that we can achieve when multiple swarms are considered. And basically we can express it as a bitrate, as a function of bitrate of content swarms, as a arrival rate or popularity of content, you can say, and basically, and the duration of content. So I will skip the details, but just take a note that we have a mathematical toolkit that we will further use to measure how much gain we can achieve. On the other hand, we have a data set of accesses to BBC iPlayer in London for September 2013, which accounts for around 2 million users, and the requests are coming from around 1 million IP addresses. And this all accounts for 15 million, up to 16 million sessions. So the average traffic that we generate is around 6 gigabits per second. But obviously, this figure can grow like order of magnitudes higher for the peak times. And basically, the records that we have in our data set are basically logs, log records like this, where we have like network ID, which is some sort of anonymized IP address, because due to legal concerns, BBC cannot give us the exact IP addresses of the user. Then we basically know the ISP or the network from which this request is coming. We know the user, some sort of anonymized user ID. We know the request time, duration of that particular session is how long actually of content was watched in these settings. And we know the bitrate and the content that was watched. And so having this analytical model and on one hand, and building a simple simulator on the other hand, where we use the BBC iPlayer data to basically simulate how would it work in a given settings, we get some results. So basically, the curve here describes what we have get from our analytical model, and basically it links the gain that we potentially can achieve from peer like from using peer assistance in content delivery as a function of the swarm capacity. And we take two use cases. On the left, we have a series of bad education, which was super popular, an episode of bad education, which was very popular in September, and on the right we have some other less popular episode, and basically different colors here show like what gain we can get in different ISPs, and we also consider like the two different bit rates. So basically, what it shows us is that for the very popular content, which is on the left, we can get really like impressive traffic savings in these particular settings. Yeah, we also show that basically modeling is in a good agreement with simulation. So basically, you can take advantage of the model. So to basically analyze why we were getting those good gains for when we tried to split the content swarms across different ISPs and also bitrate formats, we analyzed like how the traffic is fragmented across ISPs and across bitrate formats. And not that surprisingly, but we found that basically top, let's say, 8 different ISPs generate more than 80%, more than 70% of traffic in BBC iPlayer. And we also found that basically there are only 2 main bitrate formats dominating in our data set, which accounts for more than 70% of user sessions. So basically what is happening is that if we divide our like content swarms for peer-to-peer communications, we get these few big swarms for each of the ISP and each of the bitrate. And those other ISPs and other bitrates, they account for a very small percentage of sessions, which we don't really care about. So then we also look at how partial participation influence, let's say, gains. And basically, we see that basically partial participation is sort of a critical obstacle here, because on one hand it's a bit critical because it's not easy to convince users to share their upload bandwidths, and on the other hand it proportionally decreases the swarm's capacity, and so that the resulting gains are getting lower, even like for a popular content. We also found that basically the model that we explore here is that a user stays online as long as he is watching content, and this is something that is really happening with BBC iPlayer users, that if there is a one hour episode, let's say a user is watching it for 1 hour, he will most probably be staying online for that hour. And we assume basically that as long as he is watching it, he is staying online. And we compare that model with the like more previously considered in the literature model, well, basically where users were staying online only when they were downloading things and were immediately leaving the system once the download is completed. So basically, what happens is that if user is on a very high broadband connection, then he quickly downloads the episode and leaves from the system, and so that other users can only benefit from a short period of him staying online. And so the capacity of these content swarms is decreasing significantly. So these are 2 quite critical factors that we found. So before we looked at a single content swarm, so I just took use cases of 2 content items. Now we try to look what happens if basically we consider it across all the content that we have in our system. And basically the figures are quite high, I would say, so that we can get more than 50% of saving across the top, let's say, 7 ISPs among considered. And the reason for that is basically that the popularity of the content is really highly skewed. So the 5%, the top 5% of content items account for more than 80% of all bytes that is transferred in the system. And what actually happens with BBC iPlayer is that the content, so it's on-demand platform. But what is actually happening is that users can also watch live content with BBC iPlayer, but for that you need a TV license. So there are many of these users who do not have the license, and they come to watch to catch up with the episode that was recently released just after it was released. So what we observe. So what we actually observe is that few hours after broadcast, there is a huge spike for that content, and so and then it's sliding down. So basically, there is a huge swarm happening just after like next hours after broadcast. And then adding the skewed popularity distribution, where major or small number of very popular content items account for the majority of the traffic. Basically what happens is that these huge swarms with high traffic gains compensate all the rest of very unpopular content. We also found some interesting patterns. For example, that the gains or the performance of this peer-assisted scenario was performing particularly good on Wednesday in September, and we link it with the fact that basically the most popular content item, which is this bad education series, were released on Wednesdays, and so you've seen these huge spikes. All right, so we get these gains, but then we start playing what else can we add here. And basically in peer-to-peer literature, there are like two main approaches to even more boost the availability of content in peer swarms. And so that we try to see if we can also use that to improve our traffic gains. And the one approach is basically content bundling. When you put super popular content in a bundle with like very unpopular content. And so since the super popular one is really available because it's the arrival rate or the request rate for it is high, it means that you also boost the availability of unpopular content. And another approach is basically explore some caching, some user-side caches, where basically we save something on, we store the recently watched episodes of users or on their machines, and then we make them available and share them next time the user comes online. So our results, basically, I will probably skip this maths bit. Here, just the intuition is that when you put a content bundle, so there are two forces, there is trade-off between two forces. On one hand, you improve the availability of that bundle altogether. So you can basically, so you assume that the availability of unpopular content will slightly rise. But on the other hand, you put some overhead because you push these huge bundles each time someone wants to watch only like one program on something. And while it works quite good for the availability aspect, for the traffic gains, our results show that basically the maximum you can save is only, so the maximum additional gain that you can add by applying this content bundling technique is not really high, is not going over like 2.7%. While the historic caching really helped to improve a lot, and basically here we show like again the same curve and how the capacity of a swarm increases if we add caching. So the circles of small radius is what we had before we added this cache, and then we added this cache, where basically you store this, you store what you watched before, and you share it next time you come online. And we see that the capacity is increasing, and so that gain is increasing too. And overall, across our content corpus, we found that this simple caching technique with caching up to like recent 10 items can boost the gains for up to 15 to 30%. So this is basically it. A few conclusions. We modeled this peer-assisted content delivery using this analytical model and using the BBC iPlayer traces. We found that a few high popular items can obtain very high gains and hardly affected by these the first two obstacle factors, which were like ISP-friendliness and the stratification by bitrate. But we also found that basically partial participation and online models, so the time that you spend online are quite critical factors. We found that basically the gains were quite high across the content corpus because of this highly skewed popularity distribution. And we showed that basically some help with caching can even like higher add to performance. And that said, basically this is a research work which we use some modeling tools to play with it and show how it works. But I will really like your feedback to understand how feasible it is to implement in realistic scenario, let's say. Thank you very much.
Okay, so I see a question from Dave and further back, and we need a microphone.
Hello, it's David Gross from Sky here. I've got a lot of content to distribute on my network, and this kind of stuff is interesting to me, but is this entirely theoretical at the moment? You haven't got a version of iPlayer that does this, or? So
so we use the realistic traces, right, which we got from our partner from BBC, but this is models. This was not deployed in any sense.
Would you be interested in some more data?
If BBC will be interested and we convince them with our results, yeah, that would be really nice to try.
I'll talk to you later.
Okay, and then Dave at the front here.
Hi, David Freeman, Clarinet. Don't many providers habitually squash or want to squash peer-to-peer traffic?
So as far as it is localized inside ISPs, so inside their networks,
yeah,
I don't think there is a problem. At least I talked with one ISP, huge one, and they didn't see a problem, and so I don't see why it should be a problem for them. I think so the main concern was that so you have to give some incentives for users, right, to participate in this. But because what happening is that they share their upload bandwidths to help like BBC save their traffic, right? So you have to give them some incentives. But for ISPs, I don't think there would be a problem.
Okay, Neil.
I think to answer Dave's question, I don't think you probably haven't bought broadband recently, is my guess. But the notion of doing DPI is just, it's gone. Basically, the traffic that's out there is DPI. It's DPI for peer-to-peer. It's such a tiny part of the network traffic. I mean, it's almost negligible. So, I mean, we turned it off ages ago. I think the guys on Sky have done that, and I'm pretty sure TalkTalk have as well. So DPI tends to be used for traffic analysis. The guys in PlusNet do some interesting prioritization, but it's gone. It doesn't scale, frankly, and it costs a fortune.
Sounds like some data on that would make a great presentation, actually.
Oh dear. Yes. Yeah, fine. So yeah, I mean, we can. Yeah, I think it'd be good to do that, and maybe some of my colleagues in the other big ISPs would support a presentation, because I think it's interesting. But the traffic flows are just so different now. It's insane now. Basically, TV and Netflix are the drivers.
Virgin still state they can't get it.
Yeah, but I think it's for different reasons. I think they have DOCSIS has more challenges upstream. There's maybe even a DOCSIS expert hiding in the cupboard up there somewhere. But DOCSIS has real. The more upstream you use, it has a really negative impact on the downstream. And I think it's used to manage that rather than manage peer-to-peer traffic specifically.
So I want to add here. So one thing that we are also looking at, again, it's a bit like modelish, but what we were trying to look is basically what happens if you loop the traffic, for even like inside like exchange point inside the ISP. So then basically you can also try to save some energy here, because because the number of the path that the traffic traverses from the even CDNs to users, to peers, is longer. And so basically we are trying to see if you can even like save more energy here. And so like some.
Okay, one more question from Martin.
Yeah, Martin Levy, and actually maybe this is sort of a question for many people in the room. Terms and conditions of the license of using such software or device. If a device decides to, of its own accord, or a piece of software decides of its own accord, to become a peer-to-peer file sharing platform, how, and I assume, by the way, that no end users ever actually read terms and conditions, they just click the OK button, accept button, whatever. Has this come up in conversation in any way? Because this is really fundamentally changing the end user's bandwidth model, and most users won't realize that, let alone the service providers that they're connected to. Has this come up in conversation in any way?
So as far as I understand it, the BBC owns, so they have this their clients for every platform, right? So basically, it's in their power to basically change these terms and conditions if they want, or.
It's not change. It's the end user. What do they think? I mean, it's not so much the ability to change the terms and conditions. It's the it's what, in your example, the BBC is projecting a fundamental change in bandwidth towards its end users. Today, they think of it as accepting bandwidth. Then they become transmitters of bandwidth.
So generally, that's the concern that everyone raises, is how you like convince people to participate in it. And there is no question, no good answer that I can give you right now, unfortunately.
Anton Ivanov, Cisco. I am having a deja vu here, just asking the room if I'm the only one. I believe BBC started with a peer-to-peer client for iPlayer before going to Flash. Am I right?
Yeah, but yeah, that was the case, but that was in 2000, I think 5, 6 or something, and it didn't go well. I don't know why. But I think the conditions at that, and the scale and everything else was different at that point of time. Yeah. So, but that's right. They started initially with some sort of peer-to-peer model in 2006. Yeah.
Okay. Thank you very much, Dmytro.